Hello. Good afternoon, students. Last week we have seen the problems in the unit 8. So we have seen about the non-homogeneous and homogeneous system of linear equations. So in that I have told about the system of linear homogeneous equations. That is, on the right hand side you will have the value as equal to 0. So that problems we have seen, and working rule also I have told. That means three cases will arise when r equals to n. You will have no solution, and when r is less than n, you will have infinitely many solutions, and when m is less than n. So these three conditions we have seen. On that, even I have told one problem also. So we have seen all the conditions, three conditions we have seen. So first one is system of linear homogeneous equations. So for this, we'll see one example problem. So first one is x plus 3y minus 2z equals to 0. X minus 11y plus 14z is equals to 0. Okay, these are the three linear equations given in the problems. For this, we have to first find the rank of the matrix. After finding the rank of the matrix, and if you get 2 or 3, any rank, after in this given question, 3 unknowns are there, that is x, y, z. So n value is 3, and we have to find small r value. If both r and n are same values, if you get means you will get that means no solution will be there. But if you will get it is less than that is r is less than n, then you can find the other solutions. Okay. First we will write the quotient of the matrix. The quotient of the matrix is matrix A is equals to, here whatever the unknowns are there, x, y, z, their quotients we have to write. That is, first one is 1, next one is 3, next one is minus 2, next to 2, minus 1, 4, next to 1, minus 11, 14. Okay, this is A value. And here x value is, that is capital X is equals to x, y, z. And next constant, that is 0 is equals to 0. Okay. So we know that system of homogeneous equations will be in the form of Ax equals to 0. So system of homogeneous system of linear equations will be in the form of Ax equals to 0. So here A are the quotients x, y, z, and here it is 0. So A value is quotients of x, y, z. Capital X is x, y, z, and O is, that is whatever the values are there on the right hand side, those are the values. Okay. Now we have to find the rank of this matrix A by converting or by reducing it into echelon form. So we know already about the echelon form. That is, first element of the first row and first column is 1. After that, whatever the elements are there in the second row and third row, we have to convert them into zeros. Okay. So whatever the non-zero rows are will left after doing the echelon form, that will be the rank of the matrix. Okay. Now already here 1 it is there. You have to make this element as 0, next this element as 0, next this element as 0. If possible, you can make the element this also as 0. Okay. So for that, first element, whatever it is there, correct is there. But next, reducing matrix A into echelon form. Okay. So now we are taking the matrix A, that is here 1, 3, minus 2, 2, minus 1, 4, 1, minus 11, 14. Okay. So you have to convert this as 0 and second one, third row element, whatever it is there in first column, that element is also 0. So for this one, you have to write it as this is R2. That is R2 minus 2 into R1. Next, this is R3 minus R1. R3 minus R1. So now it will be converting into first row like that only. 2 minus 2 is 0. Minus 1, minus 2 means this is minus 6, minus 1, minus 7. Next 4, this is minus of minus is plus 4. Plus 4, it is 8. Okay. Next 1 minus 1 is 0. Minus 11, minus 3 means minus 14. Next 4, minus of minus is plus 2. It is 16. Okay. Now if you observe this one, whatever the second row elements are there and whatever the elements are there in the third row, if you multiply with 2 for the second row and if you subtract it with the third row, then whatever the elements are in the third row, they all will become 0. By seeing this, we can understand that we can get the rank of the matrix as 2. Okay. So R3 is R3 minus 2 into R2. So what will happen? That is 1, 3 minus 2, 0 minus 7, 8. Next 0 minus 0 is 0. This is next minus 14 minus of minus 2 means it is plus 14 and minus 14. So it is 0. And here it is minus 2 into 8. So minus 16 plus 16 means it is 0. So here the number of non-zero rows are 2. This whole row has become 0. So the rank of the matrix is 2. Okay. So here you write the number of non-zero rows equals to 2. Therefore, rank of A is equals to 2. And this value is small r. Okay. And number of unknowns are, that is x, y, z. So the number of unknowns are 3 and r value is 2. Therefore, both are not equal. So you will get the solution here. The number of unknowns equals to the number of unknowns. That is n is small n is equals to 3. So we got r value and we got n value. So r value is 2 and n value is 3 means r is less than n. So second case arises here. R equals to 2, n is equals to 3. Therefore, r is less than n. Okay. So we have r minus n solution. So r So see the last week I have given the cases are there, three cases are there. So in that you see the conditions. From that n minus r means n minus r is equals to n is 3. 3 minus 2 is equals to 1. So we'll get one linearly independent solution. So one linearly independent solution we'll get. And here we have to write we assign, that is one linear independent solution. So one arbitrary constant, we consider that one arbitrary constant C to the variable Z. That means in place of Z, we have to write C. So now system can be, whatever the linear equation is there, no linear system, that we can write in the form of Z form. That is in place of Z, we have to write C value. Now, system can be written as so what is the first equation? X. Here whatever the after converting into echelon form, whatever it is left, you have to write in that one. This is x plus 3y minus 2z. X plus 3y minus 2z is equals to 0. Next minus 7y plus 8z equals to 0. Okay. This is equation 1. This is equation 2. So from equation 2, we can write here minus 7y equals to minus 8z. So minus minus will get cancelled. Y is equals to 8 by 7 into z. And what is z? We are taking the z value as c. So if z equals to c, y value is 8 by 7 into c. So we got the y value. If we substitute this value in z, so if we substitute y equals to r by 7 into c in first equation, then you will get the x value. Why? Because already z value is c, no? Substitute in 1. So if you substitute in 1, x plus 8 by 7 into 3 minus 2c equals to 0. Now if you simplify this one, 8 3s are 24. This is 7x. If you do the cross multiplication, so 7x plus 8 3s are 24 minus 7 2s are 14 minus 14c, and this is c is there, no? 8 by 7 c, 3c. So 24c. 24c minus 7 2s are 14c is equals to 0. That is 7x plus 24 minus 14 means you will get 10 plus 10 plus 10c is equals to 0. So 7x equals to minus 10c implies x is equals to minus 10 by c. That is minus 10 by 7 into c. So we got here x value, and this is the y value, and this is the z value. So we got one linearly independent solution for the given system of homogeneous linear equation. So therefore here you write therefore x equals to minus 10 by 7 into c, y equals to 8 by 7 into c, and z equals to c. Okay. So this will constitute a solution for given system of equations. Okay, for non-homogeneous or homogeneous, the process is same. We have to first find the rank of the matrix A, and after that we have to see what are the how many non unknowns are there in the given problem. So that you have to write as a n value and rank as a small r. Then if it is equals to means you will get no solution. If it is less than means you will get 1. Depending on the n and r value, you will get the number of, if you have 4, 4 minus 2 means you will get 2 linearly independent solutions. It depends on n and r values. The procedure is like this. So whenever we will take here as a one linearly independent solution, then we have to assign one arbitrary constant c to the variable z. That is, in place of z, we have to take the value as c, and with the help of that, we have to find x and y values. So that will be constituting the solution for the given system of equations. So example problems are there in your textbook, and also exercise problems are there. So try to solve the problems of homogeneous system of linear equations. So next one is system of non-homogeneous linear equations. So next, the form of non-homogeneous. Homogeneous will be in the form of ax equals to 0. Non-homogeneous will be in the form of ax equals to b. That means on the right hand side, you will have the values. So with the slight difference will be there for solving the problem. So next one is system of linear non-homogeneous equations. Systems of linear non-homogeneous equations. Linear non-homogeneous equations. So these will be in the form of ax equals to b. Okay. So ax equals to b means we can consider that here the elements will be there. Homogeneous means here b value will be all zeros. So here the equations will be like this: a11 x1 plus a12 x2 so on up to a1n xn is equals to b1. Next a21 x1 plus a22 x2 so on up till a2n xn is equals to b2. So like this and even like this. If you take so on a m1 x1 plus a m2 x2 plus a mn xn is equals to bn. Okay. So these whatever the coefficients are there, those are a values, and x1, x2 up till xn values are capital X, and b1, b2 up till bn values are capital B. Okay. So then the whatever the linear equations will be there, those will be in the form of ax equals to b. So for this one, first we'll find the a and x. Here multiplication, it is equals to b. Now for this one, we convert the that is coefficient of the a values. A values are the coefficient of xyz. That whatever the matrix you will get that value, and if you combine it with the constant values here, b1, b2 values are there, no, then we call it as an augmented matrix. Okay, that will write it as AB. So we convert that augmented matrix into the echelon form and will find the rank of the matrix. Here, the conditions will be for the matrix A, we have to find the rank and we have to find the rank of augmented matrix, that is AB. So it depends on that same. Similarly, first case we have seen no homogeneous. Like that only here also three cases arise when matrix, that is a rank of the matrix A equals to rank of the AB augmented matrix, then no solution. If rank of matrix A is less than AB, then you will get the independent, that is a infinitely many solutions. So these also, here also you will have the working rule will be there for this. Okay, if you write like this AB, it is called as augmented matrix. This you have seen already in the Gauss elimination method, Gauss-Jordan method. So there we will use the combination of the quotient of matrix and also the whatever the constant values are there on the matrix, that you combine, and then if you write the matrix, then we call it as augmented matrix. Okay. So the working rule for this one is, so this whatever the AB will be there, reduce AB to echelon form. First thing is you have to reduce it to echelon form. And case one is, first case is, if rank A is less than rank AB. If rank of A, what is the A means quotient matrix. If that rank is less than rank AB, then AX equals to B. AX equals to B is inconsistent. Okay. Is inconsistent. Means no solution. Next one, case 2. So rank A is equals to rank AB. So then it is, then AX equals to B is consistent. And we will have and possess n minus r linearly independent solutions. Okay. So these two, and one more third rule is there. If r equals to n, then n minus r equals to 0. So you will have, in this only one more condition is, if r equals to n, then n minus r equals to 0. That means unique solution. So just if you remember these two, it's enough. Okay. In the question also, he will ask, show that the given system of linear equations is consistent or is inconsistent. In the question itself also, sometimes they will mention that one. So this, whatever the conditions are there, you can see in the unit 8. Page number 92. Okay. If rank A is less than rank AB, then the equations AX equals to B are inconsistent. That the given equations have no solution. So just if you know what is inconsistent and what is consistent, it's enough. On that only you will get the questions. And these non-homogeneous equations you will get for the 10 marks questions. That is in the section B, you will get these type of problems. Now we'll see one problem on this. So these, if you remember, then we can solve the problem. These two conditions are important: when it is consistent and when it is inconsistent. So for this problem is 2x minus y plus 3z minus 9 equals to 0. X plus y plus z minus 6 equals to 0. X minus y plus z equals to 0. I hope this is the exercise problem. So where it is means 2x minus 3y. It is the check your progress problem. Okay. Page number 96, you have solve the given problem it is asking. So solve 2x minus y plus 3z minus 9 equals to 0. X plus y plus z minus 6 equals to 0. X minus y plus z minus 2 equals to 0. Okay. These are the three linear equations. It is equals to 0 given, so it is a homogeneous. Don't think like that. Why? Because here constant terms, here values are there. They are given here inside. If you have any confusion, you can write like this. 2x minus y plus 3z equals to 9. You take on the right hand side. So x plus y plus z is equals to 6. Next, x minus y plus z equals to 2. Okay. Now it is in the form of non-homogeneous linear equations. So here the quotient matrix, whatever it is there, it is A equals to quotient matrix. And one more thing you can write here, it is in the form of AX equals to B. Okay. A is the quotient matrix. So quotient matrix is A is equals to here 2 minus 1, 3, 1, 1, 1, 1, 1, 1. Next 1 minus 1, 1. This is A. And X is X, Y, Z. And B is here this constant value, that is 9, 6, 2. Okay. Now we have to reduce the augmented matrix. So the augmented matrix, so AB is equals to, so A values are 2, minus 1, 3, 1, 1, 1, 1 minus 1, 1. And these are the constant values here, 9, 6, 2. Like this we'll write for the augmented matrix. Okay. So now we have to reduce the augmented matrix into the echelon form, and you have to find that is the rank of the matrix. Now reduce AB into echelon form. Okay. So echelon form means first element of the first row and first column should be 1. And after that, whatever the down 2 rows are there, you have to convert that first 2 elements to 0. Okay. So first for this one, to convert this as 1, just you can interchange this one. So by applying this R2 to R1. So first we are interchanging this R2 to R1. So this 1 will go in the R1. One, one, one. Yes, 6. Okay, next interchanging now 2. 1 minus 1, 1, 2. Okay. Now this is this one. Now you have to convert this as 0 and this as 0 and this as 0. So R2 is R2 minus 2 R1. Next R3 is R3 minus R1. So you get it as 1, 1, 1, 6. 2 minus 2 means it is 0. Minus 1 minus 2 means it is minus 3. 3 minus 2. So you'll get it as 1. 9, 6 minus 6 into minus 2 means minus 12. Plus 9 means minus 3. Next 1 minus 1 is 0. Minus 1 means minus 2. 1 minus 1 it is 0. Next 2 minus 6 means minus 4. Okay. Now R3 you can divide it by minus 2. So what you'll get? One, 1, 6. 0 minus 3, 1 minus 3. This is 0. Minus by minus 2, no, divided by. So 1, 0. This is 2. So this is 1, 0. No, you have to make these two elements as 0. So this element you have to make it as 0. If possible, this element also to 0. So by applying this, we have to make 0, no? If you will do the subtraction of these two, again you will get here one value. So we can't do R3 and R1. So we have to do these two only, R3 and R2. This is R3, R3. So R3 plus, here already minus sign is there. So 1 by 3 R2. Okay. So this 3 will get cancelled. And here already minus is there. So you'll get here minus 1. Already 1 is there. So this will become 0. So echelon form means we know already it should be like this. 1 here, 0, 0. And next 0, 0, 0 like this. So first element should be 1. Next two elements are 1 element as 0. Next elements in the third row, it should be, if possible, we can make all the zeros. If it is not possible, then these, whatever the elements are there, that elements you have to make them as 0. Okay. So this will become as 1, 1, 1, 6, 0, minus 3, 1, minus 3. This is 0. Anything of this is again 0. This is 1 minus 1 by 3. So minus 1 you will get. This is minus 1. This is plus 1. So 0. Next it is plus 1 by 3. 0. So you will get here 1 by 3. Next this is minus 3 by 2. Minus 3 by 3 means 3 will get cancelled. Minus 1 will be there. 2 minus 1 means you will get here 1. Okay. Now we have to make this element as 0. So here if we do the subtraction with this element, then what will happen? This may become 0, but here minus 3 it is there, no, it will come here. So again, the process will be again going on doing. So here up, we can stop this one. Why we are not getting these values as 0? Because the rank of the matrix is 3 here. Okay. So if it is the rank of the matrix is 2 means even these two elements also will become 0. Okay. So 0, 0, 0, and these elements are they, we can't make these two elements as 0. Therefore, the rank of the matrix is 3 here, and we need to find the rank of A also. This is A matrix, no? Up till here, this is A matrix. This whole thing is AB. So matrix A is also having the rank as 3, and the rank of AB is, you're getting it as 3. Okay. So number of, therefore number of non-zero rows equals to 3. Therefore, row of AB, that is rank of AB is 3, and also rank of A is also equals to 3. So we got rank of A is equals to rank of AB. In case 1 we have seen, no? We have seen case 1 and case 2. That is, if rank of A equals to rank of AB, then it is a consistent. Okay. Therefore, rank of A is equals to rank of AB. So the system is inconsistent. So if rank of A equals to rank of AB, you have to write the given equations. The given equations are the given equations are consistent. And here, how many unknowns are there? X, Y, Z, no? So X, Y, Z means here even R is equals to N also. Second condition is what? R is equals to N. So the and hence, and since the number of rank of A is equals to number of unknowns. You are able to see no number of unknowns. That means rank of A is 3, rank of AB is 3, and also number of unknowns is also 3. Therefore, we'll have one unique solution for the given system of equations. We have unique solution for the given system of equations. We can write so now we can write the matrix equation as the matrix so this is A and value of X and value of B, that is 1, 1, 1, 0, minus 3, 1, 0, 0, 1 by 3. And unknowns are x, y, z. And it is equals to last value 6 minus 3, 1. Okay. Now you have to frame them as equations. So that is x plus y plus z equals to 6. X plus y plus z equals to 6. Next, x value is 0, y is minus 3y plus z is equals to minus 3. Last one is 1 by 3 into z equals to 1. So from this, we'll get the z value as z equals to 3. Okay. Now substitute this z in second equation. Into, so what you'll get minus 3y, z is plus 3 equals to minus 3. Implies minus 3y is equals to minus 3 minus 3. Minus 3y is equals to minus 6 minus minus will get cancel, y is equals to 2. Okay, so therefore y value is 2 and z value is 3. If you substitute these two values in one equation 1, then you will get the x value. In 1, okay. So x, what is y value? Y is 2, z is 3 equals to 6. Implies x equals to 6 minus 5 equals to 1. So therefore we got x equals to 1, y is equals to 2, z equals to 3. So this is the unique solution, one solution for the given system of equations. So like this, you have to solve the problem for the non-homogeneous linear equation, given linear equations. So non-homogeneous linear equations will be in the form of, first thing, they will be in the form of ax equals to b. Then we have to find what is a value and what is x and what is b value. So after finding a will be the quotient of the matrix, x is the variables given in the problem, and b will be the constant values given in the linear equations. So after finding the augmented matrix is nothing but combination of A and B matrix. So if you combine that, whatever the matrix is formed, that is called as augmented matrix. So next procedure is we have to convert the augmented matrix into the echelon form. By converting that into echelon form, we'll able to find the rank of the matrix. So after converting into echelon form, you have to see what is the rank of A and also what is the rank of matrix AB. So if both the values are same, that means both the ranks are same, then we call it as a augmented matrix. So if that is rank of A and rank of AB, both if you get that as the same value, then we call it as a consistent. The given system of linear equations are consistent. So, and if second condition is there, no, whenever it is a consistent, if R equals to N, that is R value is 3 here and N is the number of rows, if both are same, then we'll get N minus R, that is linearly independent solution. So here N is 3 and R value is also 3. So then we will get the unique solution. So only one solution will be there. So for finding the solution, we have to write it in the form of AX equals to B. So A is whatever the matrix left after converting it into echelon form. This is A, this is X, and this is B. Now we have to write them in the form of equations. So X, that is if you multiply this first row with this column, 1 into X plus 1 into Y plus 1 into Z. So X plus Y plus Z equals to this constant value, 6. And here 0. X value is 0. This is minus 3y plus z. Minus 3y plus z equals to minus 3. And this is 0. This is 0. Only z is left. So 1 by 3 into z is equals to 1. By solving this, we'll get the values of x, y, and z. So this is such type of problems you'll get for the 10 marks questions. By this, we are completing the unit 8. So next in the block 3, we have unit 9 is there. So in this 7th unit, you'll get only 5 marks question. In 8th unit, this problem you'll get for the 10 marks. And in unit 9, we have Cayley-Hamilton theorem is there. So the theorem is important. You will get for 10 marks question. Even state and prove they will ask. And in sometimes they will ask the to verify the Cayley-Hamilton theorem. So if you know the statement and proof of the Cayley-Hamilton theorem, easily with the help of that, there is a characteristic equation will be there. If you solve that one characteristic equation, and if you verify the Cayley-Hamilton theorem, it's enough for the 10 marks problem. And one in this unit only, problems for finding the characteristic equation, characteristic roots, and also characteristic values. So regarding of these topics also, you'll get one 5 marks question. In page number 98 and 99, you have the problems for finding the characteristic equation. So one problem we'll see for page number 98. You have the definition of what is the characteristic equation of a matrix. So that is A minus lambda I. That is in the determinant form, if we'll write A minus lambda into I, then we call it as a characteristic equation. So this is characteristic equation is only important for the even Cayley-Hamilton theorem also. So the statement is every square matrix satisfies its characteristic equation. In unit 9, so characteristic equation, we'll write it as A minus lambda I. So this is the determinant, that is A minus lambda I equals to 0 is called as a characteristic equation of A, matrix A. So with the help of this characteristic equation only, we'll find the characteristic roots and also characteristic vectors of the given matrix A. So one question of, we'll see what are the characteristic roots and also what are the characteristic vectors. So 99 page number above, you have the definition is there. So the roots of the equation, that is a determinant of A minus lambda I equals to 0 are called the characteristic roots or characteristic values or eigenvalues. Okay. We can call them as characteristic roots or values or eigenvalues. Okay. In the given question, sometimes they will ask the characteristic roots, and in some case, they will even ask the eigenvalues also. Next one is characteristic vectors is there. Vectors means if lambda is a characteristic root of a n by n matrix A, then a non-zero vector x such that Ax equals to lambda x is called a characteristic vector or eigenvector of A corresponding to the characteristic root lambda. Okay. So if you know the definition of these two, then we can solve the problems of the characteristic vectors and also characteristic roots. So one problem, only if is asking the roots, you will get for the 5 marks question. Determine the characteristic roots of the matrix. First problem. Determine the characteristic roots of the vector matrix A is equals to, it is 6 minus 2, 2, 2, 3, minus 1, 2, minus 1, 3. Okay, like this matrix will be given. For this, we have to find the characteristic roots. First one is you have to write the characteristic equation of the given matrix. So the characteristic equation of A is A minus lambda equals to 0. So A minus lambda means all I is the identity matrix. Here it is a 3 by 3 matrix. So identity matrix will be 3 by 3 identity matrix. So if you do the subtraction of that one lambda into that, only whatever the diagonal elements are there, you will get it as minus lambda minus lambda. So it is equals to 6 minus lambda minus 2, 2, 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda. So it is equals to 0. Now first you have to find the determinant of this one, then you have to equate it to 0. So determinant of this one means 6 minus lambda into these two multiplication. So we'll get 3 minus lambda whole square, minus of minus is plus, and again minus 1. Minus 2 is there, so it will become plus 2. And if you eliminate this column and this row, 2 into this one. That is 2 into 3 minus lambda minus 2. So minus of minus is plus 2. Next element is plus 2 into, if you take out this column and this row, minus 2, minus of 2 into 3 minus lambda. Okay. You can multiply that one and you can simplify. So 6 minus lambda. This is A minus B whole square form it is there. So 9 plus lambda square minus 6 lambda minus 1 plus 2 into 2 3 are 6, 6 minus 2 lambda plus 2. This is plus 2 into minus 2 minus 6 minus 2 minus plus 2 lambda. Okay, you simplify this one. So 6 minus lambda square minus 6 lambda, 9 minus 1 means you'll get plus 8. Next plus 2 into minus 2 lambda plus 8. Next plus 2 into 2 lambda minus 8. Okay. So you simplify this one and you have to find the lambda values. So 6 minus lambda into lambda square minus 6 lambda plus 8. If you multiply with 2 minus 4 lambda plus 16 plus 4 lambda minus 16. So plus 16 minus 16 plus 4 and minus 4 will get cancelled. So what is remaining? 6 lambda square minus 6 is 36 lambda plus 6 is 48 minus lambda cube minus into minus plus 6 lambda square minus 8 lambda equals to 0. So first is minus lambda cube plus 6 plus 6, 12, 12 lambda square minus 36 minus 8 means 44 minus 44 lambda plus 48 equals to 0. So if you take minus inside, then lambda cube minus 12 lambda square plus 44 lambda minus 48 is equals to 0. Okay. So with the help of the division method, you have to find the factors for this one. So by division method, we get the factors as we get lambda minus 2 into lambda minus 8 equals to 0. So the factors for this one are this. So therefore from this lambda value is 2 comma 2 comma 8. So are the characteristic roots of matrix A. Your division method is like this. Whatever here it is there, you write that one minus 12 lambda square plus 44 lambda minus 48. Okay. And first you take the root as lambda minus 2 and you find that one. Okay. So with the help of the division method, you will get the roots here. So like this, when in the question it is asked to find the characteristic roots, you have to find by taking the characteristic equation. For the characteristic equation, you have to find the determinant and you have to find the lambda value. So this lambda is called as a characteristic root of the given matrix. Okay. So next in this Cayley-Hamilton theorem is there. Next week we'll see that one.